Okay, Oak Rovers, this is a video that's going to help you solve word problems where you have to define the values, write the equation, solve the equation for x, and then put that value of x back into where you define the variables. So we'll work on number 3. And number 3 says this: Model Cars Inc. makes red cars, white cars, and blue cars. The profit of a blue car is 10 more than the profit of a white car, and the profit of a red car is 7 less than the profit of a white car. Okay, I'm going to stop right there because at this point I'm going to actually define the variables. So I'm going to do the first step where I define the variables. And it looks like they're both comparing white and red red cars and blue cars to the white car price. So I'm going to let x equal white cars. Okay? Blue cars is 10 more than the profit of a white car. So 10 more is x plus 10 is equal to the blue car. And then it says the profit of a red car is 7 less than the profit of a white car. So x minus 7 is equal to the profit of a red car. Now I'm going to read the rest of the sentence, and this is how I'm going to set up the equation, or the rest of the problem, and that's where I set up the equations. So the first part of the problem, I always define the variables, and then the last half of the problem is where I'm going to write the equation. And here are the clues that I have. If the profit on 2 red cars is 2 less than the profit on 1 blue car, and the profit on, what's the profit of a blue car? Okay, so the profit of 2 red cars is 2 less than the profit of 1 blue car. So if it's 2 less, that means I have to add, well, 2 red cars looks like this. 2 red cars is going to be 2 times x minus 7. A blue car is x plus 10. Now the profit of 2 red cars is 2 less than the profit of 1 blue car. So what I have to do to the profit of these 2 red cars is add 2 to it to where they're equal. And that's how I set up the equation for this problem. After I've set up the equation, I'm going to kind of slide it back up and I'm going to kind of work on this here. So I use the distributive property to simplify the left side of the equation. And I get 2x minus 14 plus 2 is equal to x plus 10. Then I can combine like terms on the one side. 2x minus 12 equals x plus 10. And then I can take away an x from both sides. And I have negative 12 and x over here. And on the other side I have 10. And then I can add 12 to both sides. And I am getting x is equal to 22. So the profit of a white car is 22. The profit of a blue car is 32. And the profit of a red car is 15. Now I can check that to make sure that that works. So the problem said 2 red cars is $2 less than the profit of a blue car. Well, 2 red cars is 15 times 15 or 30, and 30 is 2 less than 32. So the equation that worked out and checked. So that's how you do that problem. I'm going to do one more problem for you so you can watch these just so we can kind of get it. Okay? We'll do number 6. So when I do number 6, I'll put it on the other side of the paper. So the first thing I have to always do is define the variables. And after I define the variables, I have to write an equation. That usually comes from the second sentence, or the second part of it. The first part, where I define the variables, is where I define the variables. And then the second part of it is where I actually write the equation. I use that to write the equation. So Smedley has just drawn 2 rectangles. The length of the first rectangle is 4 more than the length of the second. The width of the first is 9 centimeters, and the width of the second is 6 centimeters. If the area of the first rectangle is 96 centimeters greater than the area of the second rectangle, find the area of each. So let's define, well actually I'm not even going to define the variables for this one, I'm going to actually draw a picture. So I have 2 rectangles. Here's going to be my first rectangle, and this is going to be my second rectangle. Now I'm not going to make them to scale, but I'm just going to draw the 2 rectangles. The length of the first rectangle is 4 more than the length of the second. So I'm going to have x be the length of the second rectangle, and if the length of the first is 4 more, that has to be x plus 4. The width of the first is 9 centimeters, and the length of the second is 6 centimeters, or the width, excuse me. So there's my defining the variables. In this case, I just drew a picture to define the variables. Okay? Now what I'm going to do is I'm going to use the rest of the problem after I've defined the variables to write the equation. And it says, if the area of the first rectangle is 96 centimeters greater than the area of the second, find the length of each. So what that means is the second is going to be smaller than the first one. So what I have to do to the second one is add 96 to it so it's equal to the first one. I'm using this sentence right here as the clue to write my equations. Well, area of a rectangle is just going to be base times height. So my area of this rectangle is going to be 9 times x plus 4. And my area of this one is going to be 6x. If I use the distributive property, I have 9x plus 36, and I have 6x there. So that's the area of the first one, and that's the area of the second one. And the area of the first one is 96 greater than the area of the second. So what I have to do is I have to add 96 centimeters to the second rectangle for them to be equal. So I'll do that like this, plus 96. Now I have an equation that I can solve very easily. First thing I have to do is I have to get it so I just have x on one side of the equation. And I'll take 6x away from both sides. When I do that, I have 9x and negative 6x, which is 3x plus 36. The 6x and negative 6x make 0, so that's just equal to 96. Then I can take 36 off of each side, and when I do that, I get 3x is equal to 60. I can divide both sides by 3, and I get x is equal to 20. So if x is equal to 20, then this has to be 24. Now to check that, I can check my answers to make sure that they're right, to make sure that the area of this is 96 more than that. I can do this one really easy. 20 times 6, the area of this one is going to be 120 centimeters squared. 24 times 9 is going to be 240 minus 24, so this is going to be 216 centimeters squared. If I look at that carefully, this is 96 more than that. So my answer checked out, and it's correct. And that's how you solve problems on worksheet number 49.